Good morning, ladies and gentlemen. My name is Dave Coleman, and I'm delighted to be here today at this important event and would like to thank the conference organizers for their kind invitation to me to make this keynote presentation. Today, I would like to speak about the evolution of spatial data infrastructures from the programs that provided their basis to the spin-off efforts we have today. After discussing some of the roots of SDI programs in selected countries, and especially here in Canada, I want to talk briefly about some of the key international organizations that support these SDI efforts around the world. Then, after introducing what I think is an exciting new area of opportunity dealing with indoor spatial data infrastructures, I'll conclude by summarizing some of the key lessons learned and a few possible future research questions. First, people have developed many different definitions of what constitutes a spatial data infrastructure. While how they're addressed and mixed varies from country to country, even from province to province, I think it's clear that all the definitions of SDI include the ingredients shown here in this slide. So let's talk a bit about the background of SDI developments here in Canada. Different control survey networks, topographic mapping, and property mapping systems used in every Canadian province can be traced back to the visions of government program managers in the 1960s and the 1970s. To use the terminology of that time, these folks wanted to create computerized land information databanks designed to inform and assist government resource management, land registration, property assessment, and infrastructure management operations. Now, while it was possible technologically to build these centralized systems, these databanks were not popular politically. Individual program managers didn't want to share control of their information. And anyway, in those days, centralized databanks conveyed the notion of a computerized big brother, and people didn't trust that. This particular version ultimately collapsed under its own weight. Now, by the 1980s, networks of mini computers and PCs had been implemented and were commonplace in individual departments. Rather than building centralized systems, people wanted to examine non-technical and technical issues associated with sharing information and linking databases on different computers together. By the 1990s, there was a larger movement to think of the integrated technical and non-technical aspects of all this as information infrastructure. And you see that vision carried on today to support all kinds of spatially informed and spatially enabled operations inside and outside government. Some of the earliest spatial data infrastructure programs have already reached or even passed their 20th birthdays. These include SDI programs from the United States, from Canada, and from Australia. It's surprising to see how the early principles on which SDI efforts based themselves were so much the same from country to country. Here's one example of such principles from Canada, circa 1995. But you can see similar ones from earlier American publications and from such efforts as EU's Inspire initiative as well. Now remember these principles. We'll revisit them later on. And lest we think the SDI movement is all about the public sector, I think one of the most important SDI stories is how non-government efforts have taken center stage over the past 20 years. In Canada, we certainly know about how Google, Microsoft, and Esri Canada, among others, have leveraged early road network data from government programs to kickstart their own efforts. More recently, and especially in some of the larger urban centers, mapping from these programs has surpassed its government counterparts in terms of content and currency. Today, these companies possess considerable production and contracting and quality assurance capabilities of their own. Further, the efforts of Google and Nokia in terms of crowdsourcing and validating of map updates has been really impressive. And speaking of crowdsourcing, no presentation would be complete without mentioning the tremendous data collection and validation efforts that define the OpenStreetMap program. Now, when you think about it, these newer initiatives possess all the same basic components as the government's spatial data infrastructure programs. They may be more streamlined and responsive to quick updates than their public sector counterparts, but they are nevertheless SDI programs in their own right. Finally, another big story of the past 2 decades is how ubiquitous imagery has become. Thanks to high-resolution commercial imaging satellites, we have very useful and often fairly up-to-date imagery covering even less developed areas right around the world. Today, these original government SDI programs are under pressure from many different fronts. There's more competition, less funding available, and increasing expectations from a much larger and more sophisticated group of both end users and politicians than ever before. We see responses in terms of new approaches to data collection, which lead to the need to more effectively consume, manage, process, and deliver huge volumes of incoming data. For example, in countries where regulations permit, and even in some where they don't, organizations are beginning to make use of unmanned airborne vehicles for imaging, mapping, and even for LiDAR data collection. These technologies present tremendous opportunities to deliver more reliable information, but also pose significant operational and institutional challenges. Volunteer Geographic Information, or VGI, shows lots of promise, but in some respects is even more problematic. Even while its value is being proven over and over again in citizen science and emergency response applications, there are still operational workflow concerns, institutional problems, and even legal issues surrounding the crowdsourcing of geospatial data to update authoritative public sector mapping products. A wonderful summary of recent examples of this, and lessons learned within government, can be found in this report here, prepared for the World Bank by Professor Muki Hackley and his research group members at University College London in the UK. Now, governments are not standing still in the face of such changes. Two recent examples shown here demonstrate how specific organizations and communities in North America are handling these challenges. The Americans' NSDI strategic plan is a good example of a very focused plan prepared by an organization with a defined mandate to provide specific goods and services to its government. Read it with that in mind. By comparison, the Pan-Canadian Geomatics strategy prepared by the Canadian Geomatics Community Roundtable is more open and wide-ranging, reflecting the much wider group of stakeholders that prepared and reviewed this document. Both are different, but equally valuable. Both may be found online. None of these programs are created in a vacuum, and the lessons learned by one organization in one country are valuable to others right around the world. I would like to take the next few minutes to talk about key organizations that help qualify, codify, and communicate those lessons learned internationally. First, the groups responsible for geospatial data and interoperability standards, notably the International Standards Organization and the Open Geospatial Consortium. Now, simple, easy-to-use technologies that work well with other technologies are almost always supported behind the scenes by very detailed, well-tested standards and specifications. These standards are the glue that hold SDI efforts together. They influence technology vendors, program managers, and end users alike to different degrees and different applications. Not much nowadays happens without them, and we appreciate the work of the small groups of very dedicated technical specialists, often volunteers, that support these efforts behind the scenes. Building on top of those standards, the Group on Earth Observations is dedicated to creating a sustainable system of systems to achieve comprehensive, coordinated, and sustained observations of the Earth. Springing from United Nations member countries, GEO provides a forum to high-level technical program managers interested especially in technical, operational, and policy issues. Check out the GEOS portal for an entry point into finding Earth observation data from countries right around the world. Staying with the UN for just another minute, the United Nations Initiative on Global Geospatial Information Management, GGIM for short, is a relatively recent but incredibly important initiative that brings together national representatives from both developed and emerging nations. GGIM aims to play a leading role in setting the agenda for developing global geospatial information and then in promoting the use of that information to address key global challenges. Check out the UN GGIM's website on the slide here to get a better idea of what's been discussed to date at the technical meetings and the high-level forums held worldwide. The International Society on Digital Earth is another important organization internationally here. Through its technical and high-level meetings, as well as its journal, the ISDE has for over 15 years provided an important forum for both governments and academics to come together. And finally, of course, the Global Spatial Data Infrastructure Association, the GSDI Association. Beginning with an international conference held in Bonn, Germany back in 1996, our association has grown to include members from national mapping agencies, technology firms, universities, and non-government organizations right around the world. One of GSDI's earliest examples of cooperation was the SDI cookbook, prepared collaboratively by multiple partners. While this is now available in multiple languages, we're also pleased to see other organizations like the UNECA and PCIDEA improve on this with more extensive efforts of their own tied to specific regions. Since its launch in 2003, our GSDI Small Grants Program has supported more than 100 projects across the globe. Historically, the program's been sponsored through a partnership between the GSDI Association, the U.S. Federal Geographic Data Committee, and the GIS Corps of ERISA. This year, we're pleased to welcome Canada's GeoConnection Secretariat to that list of partners as well. The full range of projects can be seen on the GSDI Association website, along with the final reports submitted by those beneficiaries. This is a great cause, and our association is actively seeking new funding to support this program for 2015 and beyond. Finally, perhaps the most visible accomplishments of the association are the GSDI conferences themselves. These events provide the forum for people to showcase and to analyze the technical, the operational, institutional, and even political issues affecting geospatial information management in their own countries. 14 such conferences have been held since 1996 in locations around the world, with particular emphasis on cooperation with organizing committees in emerging nations. That's quite a record. We're proud of what we have accomplished and for what GSDI hopes to accomplish in the future. Okay, I now want to take just a few minutes to speak about what I see as a tremendously important and interesting area, and that is what's happening in terms of indoor spatial data infrastructures. I don't just mean what's happening in terms of how we're mapping the insides of retail centers, industrial and institutional campuses, and office buildings. Although that in itself is valuable from both technical and business model perspectives, I want to talk instead about visions of integrating that mapping with real-time positioning and navigation, and in turn linking that to point-of-sale information and demographic information for both real-time operational and longer-term strategic planning purposes. On the indoor positioning side of things alone, different technologies are emerging and competing consortia of companies are forming to promote those technologies as potential new de facto standards in the marketplace. Building atop certain technology choices in this regard, companies like Google, IL411, Point Inside, and others are creating detailed maps of the insides of stores, hospitals, distribution warehouses, and office buildings. And by insides, I don't mean just floor plans necessarily. In some cases, this mapping may include more detailed graphical and attribute information concerning retail content, hazardous materials, people's office locations, and so on. Atop this new base, new startup companies like IL411 and others are already building integrated services that, for example, assist customers in finding the products they need in a large store. These same technologies also assist the corresponding retailers by providing valuable information concerning different customer paths or trajectories through their store, where they stopped, and ultimately, what they purchased. Now, while it's still in its infancy, insights into the shape and components of this new field are already starting to emerge. Industry insiders like Tristan Lacroix at Indoor LBS have already taken a crack at creating a taxonomy of this industry. This chart is updated from some of his writing to include a few more recent examples. How does all this relate to the more traditional SDI we've come to know? Well, the indoor LBS or the indoor SDI, whatever it's to be called at this stage, is certainly and understandably far more industry-oriented and project or contract-driven. That said, the importance of developing integrated solutions that incorporate both technical and non-technical considerations will be important here as well. For example, while the need for widespread collaborative governance of the services inside a shopping complex may on the surface seem less important or less complicated than it is in government, tensions may already be growing between shopping mall owners interested in providing facility-wide services and major national anchor stores that plan to implement services in line with their own corporate-wide technology standards. This is worth watching. Stay tuned. Finally, I want to conclude with a few words on accomplishments and lessons learned in terms of SDI developments over the last 20 years. And to be clear, while my comments are certainly informed by the experiences of our members and many others, I speak here as Professor Dave Coleman, University Professor, rather than on behalf of the GSDI Association itself. And I want to place this in a context of evolving expectations. It is too easy and ultimately unfair to just look back through the lens of what we know today. We have to account for prevailing technologies, perceived user needs, and prevailing attitudes that were already in place when these spatial data infrastructure efforts began back in the early 1990s. We have to appreciate how successive sets of developments and standards built upon lessons learned in all those previous efforts. And in terms of those lessons learned, it's important to remember that many of these efforts were coordinated by national mapping organizations that may have possessed neither a positioning or a remote sensing focus. Along the same lines, responsibilities for parcel-based property information management may not always be a national responsibility. Sometimes it's a state or a provincial one. Now, I do think that too many years may have been spent on developing and refining the services necessary to simply discover and download digital mapping files for subsequent use on one's own computer. For whatever reason, too many SDI programs were slow to recognize the potential of transaction-based approaches to online mapping and to strengthen the infrastructure supporting location-based services. Whether that was unintentional or deliberate, this gap certainly opened up a lucrative market for private sector firms to fill, and they did a good job of that. All that said, it's easy to forget that even the earliest SDI programs started during the infancy of the World Wide Web, and their designers were making long-term planning decisions well before we all knew how the web was going to evolve. It's important to remember the important accomplishments of SDI programs as well. First, those early SDI servers provided valuable information for early forecasts of how the data would be accepted and employed by early adopter users in all sectors. It was often those national mapping agencies that also supported the international standards organizations with cash funding and through contributions of key employees seconded to standards committees. They provided people and companies with early prototypes and demonstrations of what geospatial web services may look like. These, in turn, helped people raise their own expectations of what was essential versus what was just desirable. Having geospatial data discoverable and freely available over an entire jurisdiction helped government units geo-enable or spatially enable their own internal workflows and processes as well. Outside of government, these SDI programs provided industry with valuable framework mapping data upon which to base their own products and services. And most important, perhaps, sharing the lessons learned in these programs through organizations like OGC and ISO, the UN GGIM, Digital Earth, and, yes, the Global Spatial Data Infrastructure Association all help these programs and their outputs evolve over time. So, now I have questions, and so should you. let's revisit those earlier founding principles of SDI I mentioned earlier in this presentation. Do they still hold true today? Or have things changed, and do we need new models and principles on which to move to the next generation of SDI? This slide contains some questions that academics might consider to drive future research. And while we're on that subject, there is certainly no shortage of technical, operational, and policy-level questions that might also encourage future applied research. For example, with operational planning, quality assurance, and even licensing concerns, how are regional, national, and global SDI programs going to incorporate the use of such, quote-unquote, unconventional data collection platforms as UAVs and crowdsourcing using data from GPS-enabled cell phones? What are the steps required to reliably integrate output from indoor location-based services with customer service, security, business intelligence, and point-of-sale systems? There are real operational and strategic benefits to using such information, but also some significant ethical concerns to the unconscious versus conscious use of such services as well. Big data researchers and possibly lawyers will be spending time on this one. And finally, as I mentioned earlier, can we draw parallels between private SDIs and emerging indoor SDIs with the more traditional models developed over the past 20 years or more? Will there be similar challenges over shared governance and collaborative use, or will the industry-driven nature of these services result in much smoother and more streamlined control? So, those are just a few of many SDI-related research questions that can be posed. And I know there are some excellent researchers at universities right around the world, including some in this conference hall today, who are now looking at these and important other questions as well. Okay, let's sum up here. In today's presentation, before offering those research questions and summarizing key strengths and weaknesses of early SDI efforts, we explored some of the components of emerging indoor SDIs, or indoor location-based services. Before that, we looked very briefly at 6 different international organizations now actively supporting, each in its own way, the development and refinement of public and private SDIs right around the world. The first part of the presentation examined the early roots of public sector SDIs, some important early commercial, and, if you will, open source SDI initiatives that spun out of those early efforts. And where's the thread? Why is this important? Because to appreciate how things have evolved and to predict where new initiatives may have difficulties, it's important to understand how things developed in the first place, how they were supported, where they tripped up, and where they were successful. Thank you very much.